Hello, today we are talking about the product rule. And again, we're still working on techniques to find a derivative. So the product rule is one technique that we're going to learn. We've already learned the chain rule, and the product rule is similar. So I don't know if you've noticed, but we haven't taken a derivative of a product. And a product is when we're multiplying two functions. So we don't have an inside and outside, we actually have two functions. So if we have f of x is equal to x squared times sine of x, that's a product because we're multiplying x squared, and we're taking that, we're multiplying it by sine of x. So let's just take a look at this and see what's going on. I'm going to scroll down a little bit. So we're going to look at this function, f of x is equal to x to the fifth, and we're going to look at it two different ways. And we already know how to find that derivative with the power rule. And what we're going to do is we're going to apply the product rule after we rewrite f as x squared times x cubed. So first of all, when we are multiplying things that have exponents, as long as the bases are the same, we add the exponents. So that is the same as saying that we have x squared times x cubed is the same as saying f of x is equal to x to the fifth. So let's make sure we know those two things are actually the same. We're just going to do it two different ways. So first of all, we're going to use the power rule. So from our derivative, we're going to take our exponent down in front, and then x is raised to 1 minus that exponent to the fourth. Now I'm going to do the product rule, and I'm going to call x squared my first term, and I'm going to call x cubed my second term in my product. So when I go ahead and take this derivative, I'm just going to show you what it is. I get this. I get the x squared, and the x squared is going to be times 3x squared, which is blue, so it's related to the second function, plus x cubed times 2x, which the 2x is red, so it's related to the red function. And what I really did, if I were to say that in words, is I did the first function times the derivative of the second function plus the second function times the derivative of the first function. And let's see how this pans out. So if I were to simplify this a little bit, my first thing here is really 3x to the, I have a second, so that's x to the fourth. And then my second thing over here, I have a 2, and I have an x to the third times an x to the first, which is to the fourth. If I were to combine those, because they are the same, I have an x to the fourth and an x to the fourth, that's 5x to the fourth. So first of all, I just want to point out, we got the same thing, whether we use the product rule or we use the power rule. So my point is, you have to use the product rule whenever you have a product. I'm going to scroll down. So let's talk about what the product rule is. Scroll a little too far, sorry. So written in words. And so just like I had said before, I'm going to take the first function and I'm going to multiply that times the derivative of the second. And then I'm going to add that, so plus the second, and I'm going to multiply that times the derivative of the first. So that's sort of what I'm saying in my head as I do it. If I were to write this in symbols, then my symbols would be f prime of x is going to be, and this is going to wrap around, that first one, which is u, times the derivative of the second one, and again I'm adding, and then I have the second one times the derivative of the first one. And if you don't like the prime notation, that's the same as u, we could say, times dv, and then plus v times du. Now, whichever way makes sense to you, That's how I want you to think about it. So if you like the words, go with the words. If you like the symbols, go with the symbols. It does not matter at all. So let's look at this one down here. I've labeled it as a U try, but I actually would like to talk about it before. So the first thing, when you see one of these, we now have too much information almost. So we have to decide, do we have a chain rule? Do we have an inside and an outside? And when you look at this one, x is being squared, and then I'm taking the sign of just x. So I don't actually have a chain rule. Next, you're looking for a product rule. Am I multiplying two functions together? And I do. The first function is x squared, and my second function is sine of x. Finally, unfortunately, we have to look for, do we actually have both? And because we had already said no to the chain rule, we don't have both. So I would like for you now to give this one a go. So please pause the video here to complete this U try. Here is the answer. I have left it unsimplified. Please leave your answer unsimplified. If your answer is correct, you're continuing with the video. If your answer is not correct, pause the video here and see if you can figure out what I've done. Moving on to the next one. So we have an example with a chain rule. So I'm already telling you, I'm already prompting you right here, but that should be part of our decision making. So do I have a chain rule? Do I have an inside and an outside? And when I look at this, when I look at my cosine, I have a cosine of 2x, so that's a chain rule. And then I have something is being raised to the third power, so that's also a chain rule. So I do have two chain rules within a product. I also have a product. So I have a yes to my chain rule. I have a yes to my product rule. So the question is, do I have both? And I have a yes. So I've got to be a little more organized in what I do with this one. So what we're going to do is we're going to start with our chain rule, our product rule. And so I start immediately with the first. I should probably write down that I'm taking the derivative. So the first is cosine of 2x. So that stays the same. That's my product rule. That's my first. Then I'm going to do the derivative of my second. That's my chain rule. So I have an inside and I have an outside, something cubed. So I'm multiplying by the derivative of that. So I take the derivative of the outside, which is 3 times my inside, now raised to the second power, and now I need to multiply by the derivative of that green inside, and the derivative of that green inside, luckily, is just a 1, because I have an x minus 1, so the derivative of x is 1, the derivative of minus 1 is 0. So far I have done the first term times the derivative of the second term, plus now I have the second term, and I leave it alone. Now I multiply by the derivative of the first term, and again I have an inside and I have an outside. So I have the derivative of cosine is negative sine. My inside stays the same. And then I multiply by the derivative of the inside, my inside being 2x, the derivative of that is 2. So just as a check, I did the first times the derivative of the second plus the second times the derivative of the first. And again, you don't need to simplify. You may leave it just like that. So, scroll down a little bit. I would like for you to now do this U try. So please pause the video here to complete this U try. Here is the solution to the U try. And again, just as a recap, I have the first. This is the derivative of the second. And this is the second left alone. And this is the derivative of the first. So if you need to pause the video to kind of work through that, do that here. Otherwise, we're going to move on to the next one. Here's the next one, and again, we're looking at this one. We're trying to find a derivative. So the questions, again, you're asking, do I have a chain rule? Do I have a product rule? Do I have both? So from here, I would like you to try this one. So give that one a go, and I will talk you through it in just a minute. So please pause the video here to complete this problem. Here's the solution to this one. And again, I'm just going to talk you through what we have. So I have the first, and then times the derivative of the second. I have a tangent, x is my second, so its derivative is secant squared of x. Next I have the actual second term, and then times the derivative of the first. So I have a natural log over here, so the derivative of my natural log is just 1 over, my inside stays the same, which is sine of x, which I got over here, and then times the derivative of the inside, and the derivative of sine is cosine. So if you have any issues with that one, please pause the video here to make corrections. And we are moving on to the next page. So now we have a table. So all of this is exactly the same as we have done before with a table. We're just now using the product rule. So we're going to go ahead and do part A together. So we have a product. We have f of x times g of x. That is not f of g of x. That's f of x times g of x. So let's go ahead and take our derivative. And again, I'm going to take my derivative before I plug anything in. And I'm going to have my first function, f of x, times my derivative of my second, g prime of x. And then I'm going to add my second function, g of x, times the derivative of my first. So I have this set up. At this point, I can go ahead and I can plug in the x value. In this case, my x value is 4. So now I have f of 4 g times g prime of 4 plus g of 4 times f prime of 4. So I go to my table, and f of 4 is 0. So I have 0. Now I can multiply that by g prime of 4, but 0 times anything is 0. So I don't even need to look in the table to see what that is. Plus g of 4. G of 4 is 1. So we have 1 times f prime of 4. F prime of 4 is 7. And when we work that out, we end up with just 7. So now we have the next one. In the next one, we have 2 times g of x. That's just a regular derivative like we've done before. And then we have f of x times natural log of x. That's where your product is. So what I'd like you to do right now, I want you to do this one, but I only want you to do that first line. Don't plug in any numbers, just do that first line. So please pause the video here to complete your derivative of this before plugging in. This is what I have after taking the derivative. Please pause the video here if you need to make any corrections. At this point, we have 2 things to do. We have to plug in our 1 and we have to distribute our negative. Okay, both things need to happen. So what I'd like for you to do is plug in your 1 and distribute your negative, and then come back to the video. So please pause the video here to do that. So this is what I have after plugging in the 1 for x and distributing my negative. And if you have any problems with what I got and what you got, please pause the video here. So now we're going to go hunting in our table. So I have 2 times g prime of 1. G prime of 1 is 5. f of 1. F of 1 is 4. Natural log of 1 is 0, so it doesn't matter what I multiply by. I don't need to go into the table to figure that out. So now I have, I believe, 10 minus 4, which is just 6. Moving on to the next one. So now we're doing part C, and I'll just have to go back and forth when we do our table of values. But this is a big, big, big product rule with chain rules inside. So let's go through. We have cotangent of this e to the f of x. So that's a chain rule right there. Then we have this product. We're taking the cotangent of that thing and multiplying it by that. So we have a chain rule and we have a product rule. So let's go ahead and hopefully we're going to stay organized to get this one done. So I'm going to take my first term and I'm going to leave it just the way it is. So cotangent of e raised to the f of x, as silly as it seems. Then we're going to multiply that by the derivative of the derivative of the second term. And the derivative of x cubed is 3x squared, and the derivative of g is g prime of x. So what I've done so far is the first term times the derivative of the second term. Now I need to add the second term, which is my x cubed minus g of x, times the derivative of my first term. And cotangent is a derivative that we are supposed to know. The derivative of cotangent is negative cosecant squared of the same inside times the derivative of that inside. The derivative of e to something is e to that something, and then times its inside, and its inside is f of x. So we're multiplying by f prime of x. Now don't forget there's this extra term over here, plus 4, and when I take the derivative of plus 4, that ends up being 0. So technically at the end I have a plus 0, but again we don't need to write that down. So at this point what I'd like for you to do is to plug in the 6 for the x's everywhere, and then go to your table and evaluate. You're going to have you're not going to get a single number as your answer, and that is perfectly fine. So pause the video here, plug in the 6, and try to evaluate. Here is my solution. Now the blue answer is the most simplified, so I actually suggest that you look at this step and compare your work with this step. After I did plug in the 6 and do some simplification. And then again, the final simplified answer is in blue. So if you need to pause the video here to get to that, go ahead. Otherwise, we're going to move on. So in this problem, we have this limit thing again, which is, what we're looking for anyway, is this a definition of derivative? So that's the question. And at a glance, I can see that I have x approaching pi, and in my denominator, I have x minus pi. So at a glance, it looks like it's a definition of the derivative at x is equal to pi. Now, let's see what our function could possibly be. So when I look at this, I've got these things that have x's in them. So I would guess that my function is going to be x secant x plus x squared. But then what I should be doing over on this other side is that should be minus f of pi. And again, that's the pi where I know x is approaching pi, x minus pi, so I know my derivative is being evaluated at pi. So let's see if I get that. If I do f of pi, and here I'm going to get pi times secant of pi plus pi squared. And I know that secant of x is 1 over cosine of x. So secant of pi is actually 1 over cosine of pi, and then I think about that for a second, and I believe that secant of pi is -1. Okay, so I have pi times -1 plus pi squared. So that gives me negative pi plus pi squared. So the question is this subtracting f of pi? So if I were to subtract negative pi plus pi squared, I would get pi minus pi squared. And is this the same as this? And it is. So what this tells me that I have is that I have the limit as x approaches pi of f of x minus f of pi all over x minus pi. And that is a definition of derivative. So I did all this stuff just to make sure this really is asking me for a derivative. And I haven't actually done my derivative. So let's do the derivative now. So my function that I have is x times secant x, and then I'm adding x squared. So I do have a product rule embedded in this. So I do my first times the derivative of the second, and the derivative of secant is secant x tangent x. And then, so it's first times the derivative of the second plus the second, which is secant x, times the derivative of the first, and the derivative of x is just 1. And then I have this plus x squared, and the derivative of x squared is 2x. So now what I need to do is plug in my pi and evaluate. So I'm going to ask that you do that. So please plug in pi and figure out what you get. So please pause the video here to evaluate f prime of pi. Here is my evaluated f prime of pi. So I plugged in my pi and I got a final answer of -1 plus 2 pi. If yours is correct, you're going to continue on. If yours is not correct, please pause the video here to evaluate what you have done and what I have done. So for the next one, we have two derivatives that we are finding. And right now, I would like for you to do both. So I want you to do B, and I want you to do C, and then I will put the answers up. So please pause the video here to complete both of these problems. Here are my solutions to B and C, so please pause the video here to check your answers, and when you are finished, have a wonderful day.